Welcome to the HeatWise tutorial for creating windows. So this will be a deep dive into creating different window types and diving into some of the details about which inputs matter and how they affect the outputs. So before we get going, I'll just always refer you to the quick help menu or quick help pop-up, which is always a useful tool when doing any of your inputs to see how the specific inputs will affect the outputs of the calculations. So for your window, you'll see here it goes over some dimensions and some labelings and the SHGC and U value and what they mean. I won't go into detail there for now, but I'll just show you the process of creating a window and doing all the inputs and how to interpret the outputs. So you can see we've got one window in our list here, and what I'll do now is just create a new one, hitting create. First thing to do would be to give it a name. So we'll just call this one test window. So you'll see here we've got a few inputs to enter, but before we enter any inputs, the important thing to always keep in mind is the outputs here. So you'll see that there are two outputs. There's the U value and the SHGC. So the SHGC is the solar heat gain coefficient. And there's a description here in the quick help, but I'll just describe briefly what that means. So an SHGC can range between 0 and 1. Typically, 0.9 would be a pretty low quality window. A higher quality window might be more like 0.5. The SHGC is the ratio of solar radiation that hits the window versus the ratio of solar radiation entering the window over what's actually hitting the surface of the window. So let's say you have 100 BTU of radiation hitting the window. If 90 BTU were entering the space, then you'd have an SHGC of 0.9. If it was 60 BTU, then you'd have an SHGC value of 0.6. So that value is actually highly dependent on the angle of the radiation. So there's different kinds of radiation. You'll have your direct beam radiation from the sun, so that will be completely dependent on the solar angle. So if the sun is way up high in the sky, the angle will be pretty, indirect. It'll be a pretty sharp angle, and the amount of radiation hitting the surface, or the amount of radiation entering the space versus hitting the surface will be lower actually, whereas if you have a more direct solar angle, like in the evenings or the mornings, or just certain times a year when the sun is further south and hitting a wall more directly, the amount of solar radiation entering the space will be much higher. And the radiation that does not enter the space is just being reflected away. So the glass, if you look at glass at certain angles, you'll see that you sometimes can't see through the glass, whereas if you're looking directly at the window, you usually can see right through it. The angle that you're looking at will dictate how much is reflected versus going through the window, and that's the same concept here, where sharp angles will typically just reflect off the window, but direct angles will tend to allow more solar radiation through. The other kind of solar radiation is actually the diffuse radiation, and this is just the general radiation in the environment regardless of the direct solar angle. And so this is radiation bouncing off all the surfaces around. So if you imagine just covering up the sun with some kind of shading device, there will still be solar radiation hitting that window just from all around, from all angles, and that's called the diffuse radiation. If you open up this advanced drop down here, you'll see that it actually does show the SHGC values for different angles. So you'll see 0 degree, 40, 50, 60, 70, 80, and then the diffuse radiation or diffuse SHGC value. And you'll see here that as you go to a sharper and sharper angle, the value gets closer to 0. At a 90-degree angle, the value would be exactly 0, because then the solar radiation can't really enter the space. It has to have some portion of it that is going perpendicular to the window if you were to break it down to its components. And you'll see that it skips over the angles of 10, 20, 30 degrees, and that's because the value does not change much in that range, where before between 0 and 40 it's barely changing. You'll see even going from 0 to 40 here, it goes 0.9 to 0.864. It's not a huge difference, but as you start to increase that angle, it changes quite drastically. So this is important to know because this will affect your loads. Of course, HeatWise estimates these values based on the direct SHGC value, and you'll see here that the output value 0.9 exactly matches the 0-degree angle, and that's not a coincidence here. It's because this is actually representing the exact direct beam angle. So if the solar rays were hitting the window at exactly zero, exactly perpendicularly, that's the value you'd see. It just doesn't display all the values until you hit until you drop down that list. So with that in mind, we'll now just go through entering some values. So first thing is the height and width of your window, and if you scroll down here, you'll see that a window or some kind of fenestration product will have a length and a width value, and you'll see here that a window will typically have a frame around it, and the length and the width dimensions include the frame width, and that's important. You don't want to just take the glass dimensions, you want the full frame dimensions. So you would give your dimensions. We'll just do a few arbitrary values here, but it's important to include that frame because that will make a difference in the outputs. You'll see that there's then a drop-down menu for the style of window, fixed, operable, garden window, and curtain wall, and that can impact some of the estimates made for how these values change. There's an option for a bug screen, and a bug screen will change the amount of solar radiation entering the space. So if you have a bug screen, you have a window with a certain SHGC value, and then you have a bug screen, the total solar radiation entering the space will actually be different than than the SHGC value that is shown, and that will be accounted for in the calculations. So if you don't want to include that in the calculations, then you just use none. You'll see here that there's no option other than none on the bug screen, and that's because it's a fixed window, because a fixed window would never have a bug screen. But if you go to an operable window, you then have options of interior versus exterior, so depending how the window opens. So for example, a slide up or slide down window typically has a bug screen on the outside because you need to access the window from the inside, whereas one with a handle that you twist to open the window would often have one on the interior side, and this will make an impact on the solar calculations. So that's all something for for considering, but it's not going to actually impact these outputs down here. The really important part when creating a window is whether you're going to do it with manual entry of these values or by building your window. So you can see it defaults to manual, and it defaults to a 0.9 SHGC but does not provide a default U value. So the U value is something that would typically be provided by the architect, and the important thing to note is whether or not the value provided by the architect or by the window manufacturer or whomever is providing this value is whether or not the value is for the entire fenestration product or if it's just for the glass portion. Because if you the U value will typically change throughout the glass as you get closer to the frame. It will start to usually increase that U value or perhaps decrease if the frame is well insulated. So I'll just put a value of 0.3 here, and you see that the output is just exactly what that manual input is because it's directly pulling from there, and there's no more work to be done here, nothing else to really modify. You can adjust your SHGC as well, and you'll see that all these values here will change, and they should change proportionally. So the SHGC, it's important to know that it's a very important input and output for your window, and it is often published by window manufacturers. However, the window manufacturer will typically publish the center of glass SHGC value, whereas what we want here is the actual full fenestration product SHGC, because we are looking at the entire product as one piece, including the frame, which will have its own solar heat gain characteristics, and of course the frame, being non-transparent, won't let the solar rays through, but it does affect how the whole window performs. And that's why you should be pretty careful with this. And if you're given a value from the manufacturer, it might be beneficial to give a more conservative estimate. So for example, if the manufacturer says 0.6, it might be better to go maybe 0.7 or 0.75, and that will give you a more conservative estimate for your window's performance, because it will take into account the fact that the window performs differently away from the center of glass. And it's also a 0-degree measurement. So when the manufacturers publish this data, they're looking at this value right here. That's the one that they're publishing at the center of glass. So this value can be complicated and is not always easy to find, but is actually very, very important. The U value is much easier to find, but you just need to note whether it is the center of glass U value or the entire fenestration product U value, because that U value will actually change, not just including the frame, but on the glass portion getting close to the frame, you have your center of glass value and an edge of glass value and then a frame value, and it will change with the dimensions of the window. As you have a more elongated window, you have a higher portion of frame and edge of glass area. So I'll show you now the build window function, and this is typically intended to be used when you don't know the actual manufacturer data for your U value and SHGC values. So it's a good tool to use for estimating, but if you do know those values, then it's recommended to just input them manually, with the knowledge that the HeatWise requires the full fenestration product versus just a center of glass value. So you can see here there's a number of inputs when using the build window function. We have number of panes, frame style, question of whether or not you want to use the default frame width, and then the actual frame width, which comes built in based on type, but you can just give a custom value by hitting no. The glazing, and this is referring to low emissivity coating. The panes that it is applied to, the tint of the window, the pane thickness, and the gap type. And the options that are available for any of these particular inputs actually change with previous options selected. So for example, using fixed versus operable versus garden window versus curtain wall will change some of the options in the drop-down menus. So for example, going fixed, you'll see that we have up to 4 panes of glass to choose from, whereas if we go garden window, we can only choose a 1 or a 2 pane window. The vast majority of windows for commercial buildings will be fixed and curtain wall with some operable. For homes, it'll typically be fixed and operable. So we'll just go with fixed for a minute here. And you'll see we have our 4 pane options. We have our frame styles, and of course these also change with the type of window. So you'll see we have 5 options here: aluminum without thermal break, aluminum with thermal break, reinforced vinyl / aluminum clad wood, wood / vinyl, or insulated fiberglass / vinyl. Sometimes it's a little tough to know. The important thing is to note whether there's a thermal break or not. So aluminum without thermal break is typically a very poorly performing window. The heat will transfer really fast through the aluminum frame. So for example, let's go aluminum without thermal break, and you'll see we have a U value of 1.13. But then if we go aluminum with thermal break, it changes to 1.07. It actually wasn't a huge change. From 0.69 to 0.63, it doesn't make a huge difference. Then if we go to a wood or vinyl frame, you'll see it gets even lower because wood is a better insulator than aluminum in general. So it's important to see the effects on your window output U value and SHGC as you're doing this, to make sure that the results do make sense. For example, in some parts of the world, like for example in Canada, the energy code mandates certain values for the U value and SHGC. And if your values are not in line with that and it's a new building, then you know that you probably should just perhaps make a manual entry of this. So, for example, if these inputs here were the approximate inputs of your new window and you're getting a value of 0.56, you might just say, okay, it's not worth it. I think even though I don't know the actual value, I might just go manual and hit and do 0.3 for my U value because that's the uh, energy code maximum allowable U value. It does not allow any new buildings to have U value or window U values above or below, sorry, above 0.3. However, if you don't know your SHGC value, you can try building your window like this and then manually inputting your U value and your SHGC once you've gone through your window builder to obtain that value. So if your window inputs were approximately what are shown here, you'd see an output SHGC of 0.61, but you knew that that U value was not accurate. What you could do is just say, okay, I'll go with a manual input now with a 0.3 U value and a 0.61 SHGC, because I know that after building the U value or the window, that was the value that was provided as the best estimate based on available data. Putting these inputs in just tries to estimate these values by looking through ASHRAE data from the ASHRAE Fundamentals Handbook. There's a lot of data available on window types and the various SHGC values for differing angles and U values based on all these different inputs. And so going through the process of selecting all these just pulls from that data to make an estimate. So it's, of course, never a guarantee that that's exactly what the window is going to perform like. It's just making a best estimate from that available data, which is it comes from manufacturers that may be different than the manufacturer of the window that's going to your new building. So you need to keep that in mind when going through this exercise. So we'll just go through some more of these inputs and what they actually mean. So number of panes, of course, is the number of panes of glass in your window. So if you look at this image on the side, this would be a 2-pane window. So you've got your outside environment, a pane of glass, a gap, and then another pane of glass, and then the inside. 2 is probably the most common, but for higher performance buildings, you might see 3. And on very rare occasions, you might see 4 for ultra high efficiency windows. Sticking with 2 for a moment, and we'll actually go with a curtain wall, and we'll say structural glazing for the frame. So that would be a window that really makes up the wall itself. That this is a true curtain wall. You'll see our U values currently at 0.68, but as we modify our inputs, that will change. So the standard frame width is a 2.25 inch, but of course this will be known from your architectural drawings, so it's recommended to actually change this to the proper value. So let's just say, for example, in our case we have a 2.5. Then we can move on to the glazing. So the glazing will give you a handful of options, and these options will change depending on how many panes of glass you've got. So for example, let's go 3 panes of glass, and our glazing options are now different. And you can see that we omit the 0.4 and the 0.6 options because this is an ultra high efficiency window, and you would never have that high of efficiency without having some really good low emissivity coatings. So the lower the value for this E value, the higher performance the window. So we'll go with we'll go with 2 panes again, and we'll go with the 0.5 for emissivity. So the emissivity, that means that that's the ratio of heat being emitted from that surface of the window compared to black body emittance. So you cover the window with a coating, in this case a coating that is kind of a medium efficiency, and it will reduce the amount of radiation emitted to the outside world. So you get an option of which pane to apply to, or which surface. So you see we have 2 options here, surface 2 and 3. And if we look at our diagram here, we'll see which surfaces those are. So it's one of these inside surfaces, so you wouldn't put it on an outside surface or an inside surface because that will get scratched or damaged. It goes somewhere where it's not going to be tampered with. And having lower emissivity just means there's going to be lower radiative heat transfer between the two environments. The specific location might be hard to know, and but should be published by the manufacturer. If you don't know, we recommend the Surface 2 as a best guess, but of course you want to be as accurate as you can. So we'll leave it as Surface 2 for a minute and look at our next options. So you'll see with the tint, there are no options, it's just clear. If we go with the Surface 3 though, we now have several options for the tint. So we'll go with Surface 2 and clear, and you'll see that the SHGC is currently 0.47. And if we change it to a Surface 3, it actually raised. But with the Surface 3, for panes applied to, we can actually change the tint now, because the tint will be applied to Surface 2. And the tint often is also a low emissivity coating, so you have to be careful between selecting some of these. If you had a low emissivity tint coating on your Surface 2, then you wouldn't want to add a low emissivity coating to Surface 3 and your tint to Surface 2. So it gets fairly detailed, but if we, let's say, go gray for our tint, the SHGC changed drastically. It went from 0.52 to 0.32. And that's to be expected because the tint, the whole purpose is to get rid of some of those solar gains, to make sure that you're not getting an overload of solar glare coming through the window. And this is very common for high-rise buildings in downtown in cities. You'll see they're often tinted some color like blue or a blackish color, and part of the purpose of that is to get rid of those solar gains during the daytime. They often are selective too. They'll let in some wavelengths of light for like visible light, but get rid of the UV lighting. So if we go here blue-green, slightly higher SHGC, but if we go high performance green, we get even lower, down to 0.27 SHGC. And actually, if you look here, it goes to 3 decimals, it's 0.267. So we'll just go to bronze for a minute. The next input is the pane thickness, and this is also important. And of course, this is just the thickness of each individual pane. So if you have several panes, it's the thickness of every single pane. They should be all the same typically, but sometimes they're not. If they are varying in their thickness, it's recommended to just pick the lower option, which would be the 1/8. So you can only pick between 1/8 and 1/4 inch. Other options are available, but it doesn't make a huge difference a lot of the time, so we just kind of give 2 to simplify the calculations. So if your option is say 3/8 inch, we would just recommend picking the 1/8. Picking 1/8, you'll see it does impact the SHGC, but actually does not impact the U value. And the last input is the gap type. So that's of course what is in the middle piece right here between your panes. You can have a 1/2 inch air, 1/4 inch air, 1/2 inch air, 1/4 inch argon, or 1/2 inch argon. Now, of course, if you changed your number of panes to 1, you can't add any gap. You also can't add any glazing because it's not going to be applied. If you cover up, if you remove this pane too, all you've got is a surface on the inside and on the outside, both of which can be scratched or messed with, so you wouldn't typically have a low E coating. So going back to our previous input of 2 and 0.4 and our bronze tint, we can have different gap types. High efficiency windows will typically have the argon fill. Usually a 1/2 inch would be the better one. So you'll see if we're currently at a 1/4 inch, we've got a 0.65 U value. If we go up to a 1/2 inch, it improves. 1/4 inch argon, it actually got a little bit worse, but then a 1/2 inch argon and it gets better. That's our best option. If you go up to a 4-pane window, we'll actually even get another option, which is krypton. 1/4 inch krypton gap is our best performer. Actually, in this case, based on these inputs, it's the same as a 1/2 inch argon, but depending on how we modify the inputs, it could be different between those two options. So we'll go back to two panes for a second, and I'll demonstrate the effects of changing your dimensions. Because as I said before, you'll have an edge of glass value, center of glass value, and frame value. And as you change your window dimensions, the proportion of your window that is edge of glass, center of glass, or frame will also change. Typically, the edge of glass is defined as 2.5 inches from your frame, from the inside edge of your frame. So basically 2.5 inches into the window, that's your edge of glass, and then everything further into the center is the center of glass. So we've currently got a U value of 0.54, SHGC of 0.46, and let's make this a really elongated window with as a 6 by 1, and you'll see we now have 0.77 and 0.32. So it actually made a big difference on our U value from 0.77 to 0.54. It made a pretty big difference on the SHGC as well, but the U value really changed. And that's just because so much of the glass, if we change it to such an elongated shape, so much of the glass is considered edge of glass and will not perform as well as center of glass U value. So if we change this to like a really nice square shape, you can see we get a better U value. We're down to 0.48. And if we made this a really massive window, we now get even lower. And that massive window is almost entirely center of glass, and the output U value approaches just that center of glass value, the bigger that these dimensions get. So that's just a basic overview of window inputs and how to interpret some of these and how to analyze your SHGC versus your U value. If you know the U value, it's always recommended to input it manually. A common situation is where you know your U value, but you don't know your SHGC. And that kind of a situation, we recommend going through the exercise of building your window to obtain an estimated SHGC, and then just manually inputting the values with your new SHGC value that you were able to estimate. If you do enter your SHGC value manually, it follows a very prescribed pattern of how that value changes with the solar angles. But if you build it, it will actually follow a different pattern depending on the specific type of window. For example, fixed versus operable, 2-pane, 4-pane, tinted or not tinted. The variance with the angle will change as compared to the built or the manual input SHGC values. So that's a basic overview of windows. And if you're looking for full project tutorials, that is on our YouTube channel. You can check them out there, and we will be having more videos on tutorials for other inputs and outputs for these various components in future videos.